Welcome back to Patch Math, where today we are going to continue talking about exponent rules, moving on down to quotient rule. If you've been following along so far, I have made it down to here on the list I pulled from QMath. The goal is to get through zero and negative exponent. I will not be going into fractional exponent at this time because most of my students aren't learning it yet. And the number one way to confuse a student is to give them information over something you haven't taught them. So focusing in on the power of a quotient rule. We can boil it on down. It says if we have a quotient or a fraction in parentheses and it is raised to a power on the outside of that parentheses, we can bring that power into each part of the fraction or quotient. In other words, we bring it in as a power on the A and we bring it in as a power on the B. Now, here's the thing. Power of a quotient rule often happens alongside power of a product rule and power of a power rule. So if you need help with those, please consult the video prior to this one. Looking here, we have a quotient or a fraction in parentheses with this 2 on the outside. That 2 is going to come into, now this is super important, we have some invisible grouping symbols. This numerator is in its own parentheses. This denominator is in its own parentheses. So we are bringing that 2 in to the outside of that parentheses, and then we're bringing that 2 in here. Looking closely, that looks like 4. Excuse me. That looks like 4x squared all over. Well, there's only one factor in the denominator, so that's just y squared. Okay. Now you'll see the reason I needed that. Now you'll see the reason I needed that parentheses in the numerator is because this 2 has to come in as an exponent on that 4 and an exponent on that x squared. And so that is 4 squared. And just to slow down and look at the finer mechanics of what's going on, x squared squared. And we didn't have to worry about that for the denominator because it only had the exponent of 1 there, the invisible exponent of 1. So we just brought that 2 in. This is still over y squared. All right. So 4 squared is 4 times 4, and that is 16 in our numerator. We can apply the exponent rule, power of a power rule that says if we have a power raised to a power, we can just multiply those powers. That is x to the 4th. And that y squared goes there on the bottom. Nothing else can be simplified. This is the correct and final answer to number 11 here. So sometimes you have some stuff in the parentheses that might be best if you simplify first, but I'm going to show you what to do if you don't simplify first, leaving it using the quotient, leaving it by applying the power of a quotient rule. Because on this one, if we simplify first, it will just turn into power of a product rule. And I want to show you, you can have some flexibility on these. So we have 5 here. That 5 gets brought into the entire numerator. And if we want to look at it maybe a little faster than we did the first one, that means that 5 comes in as an exponent on the 3. It comes in as an exponent on the m squared, and it comes in as an exponent on the n to the 7th, and it also comes in as an exponent on this m. So if we just jump straight to doing all of that, that is 3 raised to the 5th power, m squared raised to the 5th power, n to the 7th raised to the 5th power, and then m to the 1st power, if there's an invisible 1 there if you want to see it, raised to the 5th power, or we can just simply go ahead and write that one as m to the 5th power. And you'll see we just have a little more simplification to do. We have 3 raised to the 5th power. That is 243. Then we have m squared. It's a little messy there. Raised to the 5th power. That is m to the 10th, because that is 2 times 5, using the power of a power rule. And moving on, we have n to the 7th to the 5th power of a power rule says that is 35 there. Phew, that got big. The 7 times 5 is 35. And that m to the 5th power is still in the denominator. And now we can simplify using quotient rule. If you see here, we have a like base in our numerator and our denominator. Everything else will stay the same. So I'm going to go ahead and write the 243 and the n to the 35. And if you review the second video in this exponent rule series, you'll see that quotient rule says we can do m to the 10 minus 5 there, into m to the 10 minus 5. And so that equals m to the 5th n to the 35th. And we are done. And there are 2 examples of how you will see power of a quotient rule and likely a few other of the exponent rules we've covered so far occurring at the same time. Thank you so much for your time.